Welcome everybody to our Arduino workshop. I'm Anita Gonzalez, the Deputy Director for New Mexico Mesa. And here with us is Kevin Dilly from Explora, who is also our tech guru for all of our workshops. So if you did any workshops with us, you probably had him as an instructor. I will go ahead and pass on over to him and he'll go ahead and give the start instructions. But by now at the start, you guys all should have your Arduinos, installed, ready to go ahead and start going. If you do need to catch up for whatever reason, just go ahead and catch up. But for the sake of time, we only have the 1 hour. So we are just going to continue with the workshop as is. So I'll go ahead and pass it off to Kevin.
All right. Thank you, Anita. Good morning, everybody. Glad to have you with us today. We're going to be going over how to use Arduinos. And if anybody has never used an Arduino before, here is an example. So the Arduino is this device here, and you guys should all have one. And what we can do with it is a lot of different things. So I've got here a sample kind of activity that I've built, that it has programmed into it. So you can see that here on this white panel here that's called the breadboard, I have a number of different components, right? I have some switches, some buttons here. There's a speaker. I've got a bunch of lights, and you can see that there are a ton of wires, right? And so this is a pretty involved little activity. So we probably won't get to this today. We'll do something a lot simpler than this. But this is something that we've wired together, and it's been coded. And what it is a Simon Says game. So if you've ever played that game before, what it's going to do is it'll flash and make a sound of one of these lights, and then you'll try and replicate the pattern that it has. So like if I just press the button to start, there it's starting, and it shows the blue, so I press the blue, and then it does the pattern blue, red. So I replicate that, and I try and keep replicating it. And if I get it wrong, it gives me the wrong sound, and I have to restart, okay? So this is the type of thing that you can eventually be code and be able to create with something like an Arduino. We can control all sorts of different things, not just lights and sounds. We can control motors, different types of sensors. So there's a lot of things that we can do with the Arduino. And we're just going to start out today with some pretty simple activities. So how to control lights, how to use a sensor, some things like that, okay? So why don't we go and get started? There's kind of two things that we have to do whenever we are using an Arduino. One thing that you have to do is you have to build your circuit. We're going to build a circuit on our breadboard on this white thing, and then we're going to code it. And the coding can be a little bit tricky if you're not familiar with the coding language. And so we'll try and make it a little bit easier today. I'm going to have you guys download some pre-written code, so you don't have to worry about typing it all out, and any typos that are in there would mess up your code. So we'll get to that. But the first thing we're going to do is we're just going to learn about how to create our circuits, okay? So the first thing in learning about creating circuits is to learn about a breadboard. So this is a breadboard. Hopefully you guys all have one. And if you look on it, you'll notice that it has a lot of different holes, and these are the places where we can connect things together. We'll put in wires and buttons and lights and things like that. But we have to realize how this breadboard is built and how the connections are made on it. So I have here just a sheet of paper, just to kind of visualize how underneath the plastic, all these different holes are connected to each other. So we'll notice here on the breadboard that it's kind of divided up into different columns and rows on here. And there are some dividers between it. You'll notice on the sides, there's like black and red lines here. So the way that this is connected underneath is these two columns going up and down here on the sides, those are all connected with each other. So if I plug a wire into this hole in the top, and I plug a wire into the hole in the bottom here, they'll be connected in the breadboard. So on my paper here, I'm just going to show that along the sides, they are connected like this up and down on both sides. Okay? All the way up and down, they are connected. And then these middle ones, you'll see that there's kind of a big divider in the middle. So nothing is connected there in the middle. And these ones here that are in the middle, they go side to side that they're connected, okay? So if I connected one wire here on the top row on this spot near the middle, and this spot on the top row near the side, those ones are connected along here. But if I connected one here at the top here and the bottom here, those are not connected up and down, okay? So these ones are connected across this way, sideways for each row, they are connected. And then there is a split in the middle, and then they're connected again on the rows, okay? So these ones on the different sides are not connected to each other, okay? So that'll just give you a sense of how the breadboard is built underneath, of how they are connected to each other in there. So keep that in mind when we are putting, building circuits and putting the wires and lights and things like that in, which ones are connected and which ones aren't, okay? So the first thing we're gonna do is we're gonna build up a circuit to just control an LED light, a simple light. Okay? And so with our breadboard, what you're gonna need, I'm gonna take all of these ones out. And what you're gonna need for this are just 2 wires. We call these jumper cables or jumper wires. So we'll just need 2 of them. So we'll need 2 wires, and it doesn't matter the color of the wire, okay? All of the wires work the same. The colors are there just to help you kind of keep track of which wire is which for your own sanity. So we'll need 2 of those wires. We'll need an LED light, and you can choose whichever color you want. I've got a blue one here, so I'll choose an LED light. And we're gonna need, let me pull these things out so I have a fresh breadboard here. And we're gonna need a resistor. And the resistor that we're gonna need is one that is that has the orange, brown, and gold. Okay? So those are the different components that we're gonna need to start with. Let me just get these buttons out. Okay. So let me just bring up on my screen a wiring diagram. Let me share my screen here. And whenever you are creating—
Sorry to interrupt. Could you tell us what the measurement on the resistor was? You said what color it was.
Oh yeah, sorry. So it's a 330 ohm resistor.
Thank you.
Yep. And let me bring up the circuit diagram here, which has it on there as well. Share my screen. All right, so here we go. So this is a circuit diagram, and you'll often see things like this when dealing with Arduinos or other electronics. You'll see the breadboard and how to put it together. And you can recreate it exactly as it is. That would maybe be the safest thing to do. But you can also, as I was telling you about the how the breadboard is made, you can put it how you need so that it can make sure that you have everything making the right connections. So when we're putting this together, a couple things, okay? On our Arduino, we have a lot of different pins that are going out. You'll see them on the sides there. They have black connectors that have some like slots or holes in them that you could put the wires in, okay? And so the first thing we're gonna do is actually the first thing is to, let's look at our LED. So an LED, a light emitting diode, can produce light. And it's a little bit different from a traditional light bulb. An LED is unidirectional, meaning that has a negative side and a positive side that you have to have, that has to go a certain direction. And so on your LED, there's a couple things to help show which side is negative and which is positive. If you feel along kind of the base of the plastic, it's round around most of it, but then there's also a flat side to it. And that flat side is the negative side. On that flat side, the wire that's coming out is the negative side. And you'll also notice that the wires there are different lengths. So the longer wire is the positive side, and then the shorter wire is the negative side. So we're going to put our LED into our breadboard, and you'll just insert those two wires into two separate, in this case, two separate rows of your breadboard, and just keep track of which side is negative and which side is positive. I tend to look at the length of the wires. I find that to just be the easiest for me. And where the
sorry to interrupt. Are you supposed to be showing us? Are you showing us, or are we still on the diagram?
You're still on the diagram.
Okay,
I also
just wanna make
have
sure.
yeah.
Thank you.
I can go back and forth between the diagram and myself so that we can see those things. So go ahead and put it into the slot there, into the breadboard. And then we're going to take a wire, any color wire that you want, and we'll take the same row that has the positive side. We'll put that wire into that row, and we'll put that into the 13th pin. So pin 13 on your Arduino. Okay. And so I'm gonna stop sharing for just a sec so you can see here on mine. So I just put my light here. I put a wire into the same row as the positive side of it, and then that wire is also going to go to the 13 pin on my Arduino. Okay. Let me reshare my screen, and then we're going to have to add a resistor. So the resistor is important for our LED. So the resistor limits the amount of kind of electricity that's going through the LED. If we have too much electricity going through the LED, it'll burn it out. Okay, so the resistor limits how much there is. So we're going to get a 330 ohm resistor. It is the one. The wires that are on resistors help to tell the what the value of the resistor is, and so we're going to get one that has the orange, brown, and then gold bands on it. And it can go in either direction. When we're putting in the resistor, one thing that you will want to do actually is bend the wires so that it will more easily go into the breadboard. So if you take the wire, I'll try and give it a background so you can see. If you take the wire and the wires are straight, just go ahead and bend each of the wires so it's kind of has like this U shape to it, right? So that those legs can go into the breadboard easily. All right, and so that wire, or that resistor, let's put it in one end into the row that has the negative side of the light, and the other end we'll put it into one of those rows that is on the or one of the columns that's going up and down on the sides. Okay. And I think I said 2 wires. I should have said 3 wires. Sorry. And then we're going to take wires to fill in, or to kind of electrify those columns there. Okay. They're labeled negative and positive, and sometimes it's really helpful to be able to just create a whole column for your ground and a whole column for your input in, for your voltage in, so 5 volts. So we're going to take a wire from the negative one, which is the one that has your resistor in it, and take that and go to ground on your Arduino. And for the other column, the one that has the positive sign on it, the plus sign on it, we'll take a wire and take that to 5 volts, and put a wire to connect that. So you should have a simple circuit that looks something like this. Okay, so I've got my my wires here. I have red and black here from the ground and from the 5 volts there electrifying. So we've got a simple circuit here. And with any circuit, we need to make sure that we have power to it and such. And so there is our simple circuit. Any questions?
Oh, we need to catch up for a second.
Yeah, no problem.
I'm trying to get them all caught up.
So I'm gonna put the circuit diagram back up, and so you can see where the different things are.
Okay. So he's got a red and a black wire, guys, and a resistor and an LED and 3 wires. And we're gonna get caught up real quick. I'm gonna come around to all of you and help you. I know you're.
Yeah, and I'll give folks
struggling.
just a minute or so to make sure that yours is the same as this. And so with any circuit, we'll need to have, just like if we're creating a circuit without the breadboard, right? You're gonna need to have something that will allow for electricity to flow through whatever it is that we're trying to control. In this case, we're trying to control our LED. And you'll notice here that our positive, our 5 volts, that column, nothing is connected to it, right? So we're just electrifying these right now, and we'll use it later. But right now, nothing is connected to that column with the 5 volts. We have our ground, which is going to one end of the resistor, and then through the resistor to one end, the negative side of the LED, and then through the LED, and then the positive side is going to the 13. So through our pin there, 13 pin, we can get some electricity going through it. And so we do have a complete circuit here, okay? The 5 volts, I'm trying to remember, we'll probably use it later for one of the other activities that we'll be doing today, okay? But here we can see we do have a complete circuit. It's going from pin 13, which will be like the positive side of providing electricity, going through the LED, through the resistor, and then to ground. Okay, so that'll provide a circuit to be able to turn that light on and off. Okay. And so what we're going to do now is we're going to see what the code is that we would need to be able to turn this light on and off. And so in creating the code, we would use the Arduino IDE, okay? And so this is the coding environment that we would use to be able to create the code to be able to control our Arduino. Okay? And so if we go to our Arduino IDE, so you might have it already downloaded, or if you're using the web version, go ahead and go to that. So let me switch over to that, stop sharing this, and let me start sharing my Arduino IDE. Actually, let me just share my desktop right here. And all right. Did everybody get their their circuits created, or at least some people get their circuits created. All right. But let me get started on this next part, and we could still keep creating the circuit if we need to. But if we go to the Arduino IDE, let me just close this out. If you go up to the file menu, you can create a new one, or you can open up some examples, some ones that are already created. And so what we're going to do is we're going to download some simple examples, ones that we'll be able to create. Let me just open up a new one just quickly so you can see what it looks like. So this is the Arduino sketch. They call them sketches. And it essentially will have two parts to it. You'll have this part that says void setup and void loop. And then there are these things that have the slashes here. Anything with two slashes are just comments. So those aren't really part of the code. Those are just comments so that you know what the code is doing in that section, okay? So in this case, the void setup is where you put the setup code, and this will run just once whenever your code starts. And then the void loop one is the main code, and this is whatever it is that it will be in your code that will run repeatedly, okay? And so what we're gonna do is we're gonna download the code for these kits that you guys have, the Tinker kits, the SparkFun Tinker kits, okay? So if you open up a web browser and you just type in Tinkerkit circuit guide, it'll give you usually the first one here, the SparkFun Electronics one. This is what we want. So this is going to have the activity guide for the Tinker kits. So go ahead and just type in Tinkerkit circuit guide, and it will give you this first one here at SparkFun. And we'll click on that. Actually, we'll click on this one down here, the activity guide. And what it does is it brings up an activity guide. So it will have a bunch of different information that you can use to do it. It'll have these activities that I'm showing you, as well as a bunch of others. And we'll go to this one that says install on the side, install the Arduino IDE. And there is this option here. Oh. Actually, let's go back go back to this one. Instead of this activity guide, let's go to this one. That one was the expired, the retired version. Yeah, this is the one we want. So that first link is what we want. And then click on it, installing the Arduino IDE. And there's this option to download the Tinkerkit code examples. Okay. So installing the Arduino IDE on the navigation on the side, and then download the Tinkerkit code examples. So what this will do is it'll download some different sketches that you can just open up with the Arduino IDE, and we'll be able to use that. So if I download that, download that file, and then I can open it up. Okay. So if I'm here on my downloads, let me just go really quickly to the top. I have here, this is the download there. Okay. And this will give you a bunch of different circuits that you can download and be able to use with your Arduino. Okay. So I just want to see if folks have downloaded that. Give me a thumbs up if you have, or put in the chat. Hold on, go back through that. I can make sure that everybody gets that. Okay, so let me go through just one more time. If we go to just a Google search, Tinkerkit circuit guide. Okay, the first link here, it's the Tinkerkit circuit guide SparkFun Learn link. We'll click on that one, and it will give us, once mine loads, there we go, the guide. And on the navigation here on the right, let's click on installing the Arduino IDE, and then scroll down a little bit till you get to download the Tinkerkit code examples, and click on that. Okay, and that'll download the examples. And then if we go to our downloads and open that up, it'll give you a number of different circuits. They're numbered here 1 through 11. And we're going to be on this first one, this circuit 1 blink. And open this up and it'll open up some code within your Arduino IDE. Okay, so this is very simple code. It's just going to turn on and off that light that you have. And yeah, so then we'll download it. Okay, so hopefully everybody's with me right there. So the next step we'll do before we download it, we're going to plug in our Arduino into our computer. So using the USB wire, let's plug it into the Arduino. When you plug it in, let me stop sharing for a sec. Share my screen. When you plug it in, you should be getting a green light that's showing that it's getting power, and it'll get power through the USB cord. After we download it, if we need to disconnect it from the computer, we can plug in the battery pack. That way you can run things when it's not connected to the computer. But we're going to plug it in, make sure that it's connected, and then we're going to try and download our code onto our Arduino so we can get our LED to start blinking. Okay, so let me go back to my screen. All right, so once we've got it plugged in, we have our sketch up on the screen. We're going to try and connect our Arduino to the computer and be able to download it to it. Okay. All right. So before we upload it, we want to make sure that we have a connection to our Arduino. So if we go up to where is it? To tools, that's where it is. If we go up to the tools menu and then go down to the board, it'll have a number of boards that you can select. Select the Arduino Uno. It's the most common Arduino that there is. Okay. And it's the one that is in your kit from the SparkFun Tinker Kit. And then you'll probably go down to the port here. So it should show up. So if you have your Arduino plugged into your USB port, you'll see that there is here a USB serial selection. So, you know, you can connect things through Bluetooth and other ways, but if yours is plugged in, let's select this one for the USB serial. Just click on that one, and then so you should have it showing board, and you should have it showing your USB serial connection there to the device. And then let's go ahead and try and upload it. So the upload button is the right arrow there at the top of your sketch. We'll click on that, and it should be compiling the sketch there at the bottom. We'll see that. And then once it's compiled, it should, your lights on your Arduino, you'll probably see them flashing, some lights on your Arduino, and then you should see on your Arduino itself, we should get your light to start blinking. Now, let me stop sharing this for a sec. If on your board, so you'll notice on my board, it is blinking, right? So I have my green light on, that's showing that it's getting power. There's also an online or an onboard LED light here that is turning on and off. And my light, my LED that's on the breadboard is turning off and on at the same time. And so this one right here, the light that's on the board itself, you'll notice it has a 13 next to it, and that's the same as the pin here. And so whatever is going on and off through that pin is going in here. So if this light is turning on and off, the one on the board on the Arduino itself is turning on and off, but the light on your breadboard is not, then there's something wrong with your circuit. You just might want to check it. Maybe your LED is turned around. Maybe one of the wires isn't pushed all the way in. Maybe you're in one of the wrong pins. You're in 12 instead of 13 or something like that. So just check to make sure that your LED light is blinking on and off. So any success from folks? No? What's the problem? Is it problems with the IDE?
It's mostly us downloading the code. We didn't get the example code downloaded. For some reason on mine, I don't have a button that says download the examples. And all the frustration from my students, I'm trying to help like 16 of them at once. So it's hard. So I was just hand typing the code real quick.
Okay.
But it would really help us if you could put it back up so I can finish typing and then I can get it.
Well, what you can do, here's something else you can do. Let me put this up really quick. You can hand type it. There's also, here's something to help you do it. There is a built-in, so if you go to your file sketchbook, or sorry, file examples, there are some built-in examples. File examples, basics, and blink, okay? So open up that one and it'll have some of it already typed in there. The one thing that we'll have to change is right here where it says LED built in, change that to 13, okay?
Okay. And then everything needs to be 13, right? Like that.
Yeah, all of the ones that say LED built in, change that to 13. Because the LED built in is that built-in LED, the one that's on the board. And so it will just flash that one, but we want it to also go out to pin 13. Okay.
Oh, I forgot a semicolon somewhere. Found it.
Okay.
Guys, you're supposed to be participating. I know it's hard. Does everybody have their circuit boards ready? Yeah. Okay.
No games. My LED works.
An error occurred while uploading your sketch.
It might be, are you able to get your port there? Check to make sure that your serial, USB serial, or that you're connected to whichever one that your USB is connecting, your serial port.
Normally it's COM4. Let's see if it starts blinking.
How about others from other schools? Are others able to get theirs to work?
I didn't click that. Computer's always running slow.
But Tohachi, are you guys able to get yours to work?
Oh, we are just following you, but we are recording. It's
Okay.
because the technologist was absent. He was not able to report this week, and so he was not able to install the software. So
I'm
we are
sorry.
just recording your
Okay.
instruction.
Okay.
We will go back to that later.
Okay.
Thank you.
This is a great example of troubleshooting, right? This is something that is always needed. It's a good skill to have for any electronic things.
To be honest, mine should be working, but it's not.
Okay. Let's see. Do maybe try plugging in one of your students' Arduinos just to check. You know, always trying to eliminate all the different components to see which is the thing that's not working.
Okay, someone bring me their circuit board.
You could also try, I don't know if on your computer you have another USB port, just try it in a different USB port as well.
I have 2 of them, so that's a point.
So try the other one as well.
I think this needs to go up 1 row and then we can try yours. There we go.
Wait, what are you doing?
Trying to download a code to it so it'll work. So it'll light up.
And even if the code, even if the circuit is wrong, it should still be blinking the light on the board if it downloads.
I'm still on that.
What are you doing? About wires.
Global variable uses 9 bytes of dynamic memory. An error occurred while uploading the sketch. Yeah, you can go sit down. We're trying to get it to work. Okay, it still gives me that error message.
Okay. Well, I'm sorry if we're not able to get it to do that. Some troubleshooting that you can do is if you go to, let's see, let me just check here really quick. There should be a, let me stop sharing for a sec. Let me find a site for you really quickly to be able to troubleshoot with, be able to. So one thing that you can do is if you are unsure which is the port, what you can do is actually is plug your thing in, look at the, here, let me demonstrate it here. Share screen. This is one way to see if you're getting a connection to it, is if you are in your Arduino IDE and you see that there are at tools and click, if you're hovering over this, you can see the different ports that are there, right? And if you unplug your thing while you're in this, you should you should be able to see the ones that are there. And then let's go back to it and go to port and see which one disappeared. That's the one that is the right one. So now let me go back, I'll plug mine in. And now if I go to ports, it has it there, right? So you should see a list here. Usually it'll just be of the Bluetooth ones and then a serial port. So if it's plugged in, it should be showing up. And if it's unplugged, it shouldn't be there on the list. Are you seeing any changes when you have it plugged or unplugged? Plugged in or unplugged?
Yeah, one showed up and one didn't.
Okay, so that's the one that you should have selected, the one that showed up. Okay.
Let's see if it downloads.
Okay.
And works. Well, it did something.
Well, if something's lighting up, that means it's connected to it. It's communicating with it. So that's good. That's a good sign.
The board lit up, but not the LED. I'm gonna try a different LED in case that one's burned out or something.
Okay. Is the light, the onboard light blinking?
Yes.
Okay. All right. Yeah. So that's good. So it means that the code is on there. It's just there's something going on with your circuit then. So things to check on your circuit are check to see that the LED is in the right direction. Make sure that the wires are lined up on the right. It's really, you need glasses for magnifying glasses for some of these breadboards, but make sure that you have the wires in the right row with the LEDs and the resistor. You can also, so since it's downloaded, you can unplug it. And if you plug the battery pack into it, that one you can still kind of work on, and you could plug in other students and download theirs to their
Okay, Sebastian, come get
to their
yours.
Arduinos. Okay.
See if yours works. You're gonna have to play around with your circuit because your circuit might not be wired quite right. Okay, let's see if we can download this one.
So as you guys are doing that, I'm just going to demonstrate something that you could do to play around with the code. Okay, so if you have this code if you know that your computer is communicating with your Arduino, you can download, you've got your circuit going. Let's look at the code a little bit and see how we can modify it to change some of the behavior of your Arduino, of your circuit, right? So just looking at this, we can see that we have something that turns it on. So in this case, this code that says the digital write, it gives us 13 and high. So that means it's looking at pin 13 and it's turning it on. That's what high is. And then this code is for pin 13, making it low. And so low is turning it off. So high and low is for the circuit. It's, you know, sending the electricity through, that's high, and turning it off, that's low. Okay. And then we have a delay of 2000. So this is a delay of 2 seconds. And so we can see that this is in milliseconds. So a millisecond is 1,000th of a second. And so we can say if we have 2000 milliseconds, then that's 2 seconds. So this code, if we read it from top to bottom, is turn it on, wait 2 seconds, turn it off, wait 2 seconds, and then it loops it. It goes back to the top and repeats this. So if we change any of these numbers, the 2000s, we can change how the blinking is, like speed it up or make it slower. So if you're able to, go ahead and do that. You can change it. So on mine, so for example, on mine, you can, let me just stop sharing for a sec. You can see on my board, it is blinking and it's waiting 2 seconds, right? It's kind of a slow blink, right? So let me change this just a little bit. And there we go. I'm going to change this to, let's say, 500. I'm going to change this to 500, and I'll change this to 500. So that's going to be now half of a second, right? So it should blink a lot faster if I have this. So I'm going to download this or upload this to my Arduino. And it says it's done uploading. Oh, actually, there. Okay, so it's compiling it. And once it compiles, it should upload. Now it's uploading it. Go to mine here. And we can see now, there we go, right? It's blinking a lot faster. It's blinking half a second, right? So just changing the code that simple way can change how it does it. And if I only change one of those numbers, right, and I leave one high, like 3000, right, 3 seconds, and one is at 500, then we can see that it will stay on or off for longer. And that's how we can change the code with that, okay? So I want to get to one more thing, actually, before we're finished. I know some people have some difficulties with getting some of the things to run. But let's try one more thing. We're going to add to our circuit here. So let's go to a new circuit diagram here. Okay, we're going to add to this. So instead of just having it blink on and off, let's be able to control that with something. Okay, so I'm going to go down, and this information is available in that Tinkercad circuit guide as well. But I'm going to go down to this circuit here. So we're going to add something to our circuit. So here we have a new circuit, and it still has a lot of the same components, right? And this one looks different, but it still has this section. It has our 13 that's going to one side, the positive side of the LED, the negative side going to a resistor, and then that resistor going to the ground, okay? So you can just leave that component on your circuit, on your breadboard, and we're going to add another component. We're going to add what's called a potentiometer. So a potentiometer is essentially a dimmer switch. So a potentiometer is a knob that you can turn, and it'll change the amount of electricity that's going through, okay? And so we're going to add a potentiometer to our circuit. And so here is what the potentiometer looks like. Let me stop sharing for a sec. So it's just a small blue dial, and it'll have 3 wires coming out of the bottom. And so we're going to use this to add to our circuit. Okay, so I'm going to put this on our circuit, and you'll notice on the potentiometer it has 3 sides that are flat on it, and 1 side that is kind of like an indentation. And so we're going to have that indentation side be going in the direction, in a certain direction. Okay, I'm going to have it so that it is going towards the well, it doesn't matter which direction you have it going, just have it going in one side. So we'll plug it into the board, and we'll get 3 other wires. And you'll notice that one of those wires is going to go from, let's do the center one. The center is the easiest one to know from the potentiometer. We'll do from the center to pin AO, okay? And the A ones are the analog inputs, okay? We'll get one from the top side of it. And this one is going to go to this top one. As we see here, this in the diagram, it has a blue wire. We're going to have that go to the negative, to the ground. Okay. And then the bottom wire is going to go to the 5 volts. Right? And in the diagram here, it's an orange wire that's doing that. Okay. And so we can see here that we can do that. So on mine, I've done the same thing. So I've got here, I've put my potentiometer right there. I've taken my wires here, the center one. In my case, it's a blue wire. It's going to A0. I've taken this top wire. In my case, it's yellow, and it's going to the ground. And the other one, which is white, is going to the 5 volts. And so now what we can do is we're creating a circuit that has a potentiometer. And so it has 5 volts going through the potentiometer. And so if we change the dial on it, it changes how much is actually getting through of that 5 volts, right? I can have it be the full 5 volts. If I turn all the way down, it can be 0 volts getting through. And so we can use that to change what the LED is going to be doing. Okay, so let me share my screen one more time. And so that's the circuit. So I'm just adding to the circuit that I had before. And for this one now, I'm going to open up a new sketch. In this case, I'm going to go back to the one that was downloaded, circuit 2, the potentiometer, and I'm going to open up this sketch. And so this sketch, if we have it here, let's look at this sketch just a little bit. This one has a little more information, some different things in it, right? So we're still looking at the pin 13. This is also now having this thing that says serial begin. And so this is creating a serial connection with the computer. So the computer is going to be able to get information back and forth from the Arduino, okay? And so it's going to read what the position is of A0 from that potentiometer. It's going to read what is the voltage coming through the potentiometer, right? It has the maximum of 5 volts and minimum of 0 volts. And as I change that dial, it's changing how much voltage is getting through. And so we're just reading how much is getting through from when I change the dial. And then it's going to change the blinking speed based on the amount that's getting through. So now the delay, instead of having it be a set number, right? It was a set number before of either 2000 or 500, whatever I wrote there. Now it's going to have it be this position, which is from whatever the amount getting through through the potentiometers. So I'm going to upload this code. Let's upload it. And so it's compiling the sketch and then it will start uploading. So let me stop sharing this. There we go. And so there we go. So now it's uploaded. And so it's giving a certain speed that it's blinking. And if I turn this dial, now I can make it go faster, right? Or I can slow it down. So it's going pretty slow. And then if I turn that up, it should be going faster. There we go. All right, so we can change it now with the potentiometer. So that is an example of how we can look at not just outputs, but also inputs. So when we talk about anything with computer science or coding, you're always thinking about inputs and outputs. So it was before that we were just giving an output in our first code, where it was just turning it on and off. So you were sending this code out, turn it on, wait for 2 seconds, turn it off, wait for 2 seconds, right? So we're sending stuff out. But now we're getting some input from the potentiometer, from that dial of, how far is that turned? How can we tell how far it's turned? Is by the amount of voltage that's getting through it. And then from that, we can use that input to change the output of how quickly our light blinks. So hopefully some folks are able to get that to work, to be able to get your LEDs to blink and change the blink rate of it using the potentiometer. And so I think that's all that we have time for today. But I just want to let you guys know that resource that is there. So let me share the screen one more time. That Tinkerkit circuit guide, this one that we have here, this one is a good resource for you. It has all of these different ones. So it has these two projects that we just did, as well as other projects that you can do, and it'll build up. Even that Simon Says game, which is, if I come to that one really quick, right? You can see there's lots of wires. There's a lot of building of the circuit to be able to create that project. Okay. So before I go, any questions that folks have? I'm sorry that there were technical difficulties, but that seems to always be a thing with electronics.
I have a question, Kevin, or
Yeah.
more or less just like, curiosity kills the cat. So when you showed the diagram for the potentiometer,
Yes.
it has the 3 pins, right? So positive,
Yes.
negative, and I presume ground in the middle, correct? So basically or not ground, because that wouldn't be the right term, but it's connecting to the analog, correct?
Mhm.
The
Yes.
green. Okay, so my question here is the blue and the orange you have connected. Of course, one is positive, one is negative. Are those interchangeable? So let's say somebody's setting this up and then they end up connecting it the other way around, because you had mentioned the little lip, and then does that matter the way they place it or not? And are they interchangeable if they do it the right way? If they connect
That's
it
a
the
great
right
question.
way?
That's a great question. And the short answer is no, in the sense that what it would do is it's going to change the sign of what your result is, right? So instead of getting, so if I go back to the code here really quickly, right? So the code here will is looking for, well, actually, never mind. Actually, yes, it is interchangeable, because all it's doing is it's changing the direction that the knob has to turn for it to turn it off or to turn it on. So, so then the answer is yes. So it is interchangeable. So
as long as it's wired correctly, right? And the code matches what you wired, then it should make no difference.
Well, actually, it should make no difference, because regardless, because all it will do is change which direction the knob turns to turn it up or to turn it down. But the green wire that's getting the input from it, of the voltage that's coming in, it's still going to change. That voltage is going to change. It's just going to mean if I turn it clockwise, it's going to go up, or if I turn it counterclockwise, it's going to go up. It doesn't care which direction you're turning the knob. It's just reading if it's going up or going down. And so that shouldn't matter.
Thank you for clarifying that, because I know some people might not know the answer, or they might just be like, oh, we have to set it up this way because that's how Kevin showed us.
Yeah.
So if they know the reasoning behind it, or like that they can change it as long as it's wired properly, then it should be okay.
Yeah.
Right? Okay. Thank you for clarifying that or answering that.
You're welcome. Any other questions?
Mostly a comment. If you do like I did and you download it to each of your students' boards from one computer, you will need to change your COM port each time you plug in a new board.
Yeah, because it'll have, each board has its own identifying number. The port will still be the same, but it'll have a different number at the end. Yes. Okay, thanks. Yeah, good thing to note. All right. Well, thank you guys so much.
So thank you, Kevin. Just one last comment I didn't put in the chat. I don't know who has access to the chat, but thank you for coming today. But this first session was meant to be an introduction. So the list that we sent over, some of the resources Kevin used today on there, they have a lot of supplemental and follow-up lessons that you can do on your own, and just getting to tinker with the Arduino is honestly the best way to get to know the quirks and the ins and outs of it. Just, figure out what works, what doesn't work, the circuitry. So just playing around with it. But teachers, for credit for this session, please make sure and enter in your own attendance and your own ThinkWave roster there for going. But other than that, you guys have a great rest of the day, and we'll go ahead and end promptly at 10. Okay. So thanks, everybody.
Thank you. Anita.